Good day, everyone. So this is Engineer Melissa, your instructor in Mechanics 101, and I will be discussing to you the other methods in computing the internal forces of truss members. So last week, we are already done with the method of joints. Ngayon naman, I will be discussing the method of sections. So this is another way on how to compute the internal forces of truss members. Analyzing the free body diagram of a part of a truss that contains two or more joints is called the method of sections. It is used when the force of only a few members of a truss is to be found. Okay. So dito sa method of sections, ideal siya na ginagamit if we are only looking for specific members, no? Unlike din sa method of joints, kailangan nating isa-isahin yung every joint um, bago natin ma-compute yung isang specific member. Like for example, okay, meron tayo ditong simple truss. Okay, so ang ginagawa natin sa method of joints, di ba, is bago, like say for example, ito yung pinapakuha. Itong member na to, 1, 2, and 3. Okay, so ang ginagawa natin sa method of joints is i-complete muna natin to dito sa part na to. Tapos, proceed tayo sa ibang joints. Dito naman. So, makakompute na natin tong part na to, di ba? And then, another joint, and then the other joint, di ba? Ganun. So, marami bang procedure bago natin makompute yung mga specific members here. Unlike dito sa method of sections, we can distinguish yung forces ng mga members na to easily by using yung tinatawag nating cutting line. Okay, so we have here specific following steps. 4 simple steps we need to follow. Number 1 is to determine the reactions of the supports by using the free body diagram of the entire truss. So, i-complete muna natin yung mga reactions here of the supports. After that, imagine a cut through the members of interest, cutting the least number of members, preferably 3. Okay, so dito, magkakaroon tayo ng cutting line, making sure na yung mga hinahanap natin or the members of interest is madadaanan ng cutting line natin. Okay, so for this example, magkakaroon tayo dito ng cutting line. And then yung cutting line natin, make sure or preferably tatlo yung madadaanan niya dito. Kasi mas mabilis yung computation if tatlong members lang yung madadaanan niya. Tapos 4, 5, 6, medyo maraming complicated na yun. Pag maraming members yung dinadaanan ng ating cutting line. Okay. So next, draw the free body diagram of the two different parts of the truss. So dito ngayon, since meron tayong cutting line, ibig sabihin magkakaroon tayo ng two parts, the left and then the right portion, no? Pipili lang tayo dito ngayon ng isang portion, set aside natin siya, and then i-reflect natin yung mga internal forces. For example, dito sa truss na to, left portion yung pipiliin ko to compute these 3 members, okay? So, we have here, yan. So, set aside natin yung tatlo. And then, nandito naman yung cutting line, di ba yan? And then, mag-a-assume namin tayo ngayon ng direction of the forces. Yan. Okay. So, left portion to. Lagay natin yung joint. So, wala na tayong pakialam dun sa right portion. No? Pag left yung pinili natin. Pero pag right naman yung pinili natin, of course, i-drawing mo yung right and then i-reflect mo din yung mga internal forces on dun sa cutting lines. So, okay? So, it's either left or right, parehas pa rin yung makukuha mong sagot. Kahit anong portion yung i-consider. Okay? And then, after that, use the equilibrium equations to find the forces in the 3 members that are cut. So, i-apply na ngayon natin yung equations of equilibrium, which is the summation of forces x, summation of forces y is equal to 0, and then the summation of moment. Unlike dun sa first method, the method of joints, ito lang yung ginagamit natin, di ba? Now, in the method of sections, we can now utilize the summation of moment. Okay. So those are the steps that we need to follow in order to apply the method of sections. Okay, so proceed na tayo sa first example. Find the forces in members CD and CG of the stairs truss as shown. So CD and CG, yung pinapahanap. So this portion, CD, and then yung CG. Okay, so nasa gitna, no? Pag in-applyan natin ng method of joints to, compute natin yung joint dito. Yan, dito, dito. Bago tayo maka-arrive dito sa portion na to. So medyo mahaba pa. So by the use of method of joints, we can compute easily yung CD and CG. Okay. So first step here is to identify the support reactions. Okay, so meron tayong hinge at point A. Tatawagin natin AY. And then AX. And then dito sa E, meron tayo ng mga roller. So tawagin natin AX. Okay. So taking the summation of moment at point A is equal to 0, counterclockwise positive. So we have AY multiplied by moment arm. Sorry, summation of moment A pala. So summation of moment at A. Summation of moment at A, so we have EX, counterclockwise motion, EX, multiplied by the moment arm, so we have 4 meters. Next, may mga external forces tayo naka-apply dito sa baba. So clockwise motion naman, so minus 1 kilonewton by 4 meters. Next, minus 2 kilonewton by 3 meters. Minus 2 kilonewton by 2 meters, and then minus 1 kilonewton by 1 meter is equal to 0. Therefore, EX is equal to 6 minus 4 minus 1 divided by 4. Okay. So EX is equal to 3.75 kilonewton. And then for AX, summation of forces along X is equal to 0 to the right as positive. So we have AX minus EX is equal to 0. EX, 3.75. Therefore, AX is also equal to 3.75 kilonewton. Okay. And the next, summation of forces along Y is equal to 0, upward positive. So we have AY minus yung mga external forces, minus 1 na minus 2, minus 2, minus 1 is equal to 0. Therefore, AY is equal to 6 kilonewton. Okay, so those are the external forces, or the support reactions, I should say. So 3.75 kilonewton EX. AX, we have also 3.75. And then AY, 6 kilonewton. Okay. So we are done with the step 1. And then for the step 2, cutting line naman tayo. Cutting line. So yung cutting line na yon, we will make sure na madadaanan yung mga member of interest natin. So the member of interest is CD and CG. No? Then preferably 3 members yung madadaanan ng cutting line. Okay. CD and CG are the members of interest. Therefore, dito natin papadaanin yung ating cutting line. Tatawagin natin A. Okay. And then, pipili tayo ngayon kung right or left portion yung i-consider natin. So, it's either right or left. Kahit saan naman po pwede. Same rin yung maupuhan nating sagot. Okay. So, for me, gusto kong iset aside yung right side. Okay. So, yung right side or right portion yung kukunin natin. And then, draw the free body diagram of the right portion. Okay, so nandito yung, let's say for example, yung ating cutting line mo. Okay. And then, yung nasa joint C. Yan. So, wala na tayong pakialam dun sa other part or yung left portion, no? Then, i-reflect na natin yung mga forces na kailangan natin dito. Okay. So, dito, magkakaroon tayo ngayon ng mga assumption yung direction ng ating forces. Okay, assumption. Again, assumption lang tong mga direction ng forces natin. Okay. So, for this one, tatawagin nating FGH. FGH. Tapos, ito naman yung FCD and FCG. Yan. FCG. So, nandito yung joints natin, no? Kung saan nakadugtong yung ating mga members. So, ni-reflect lang natin para makita natin kung tension or compression ba. Okay? And then, yung mga reactions natin and external forces. Don't forget. So, EX, we have 3.75 kilonewton. And then, 1 kilonewton here. And another 1 kilonewton. 2 kilonewton rather. Yan. And then, of course, the distances. So, yung mga distances natin are all 1 meters naman. 1 meter, 1 meter. Also, here at the horizontal, 1 meter. Okay. So, meron na tayong free body diagram ngayon. Meron tayong working free body diagram. So, we can now apply yung equations of equilibrium, the summation of moments, summation of x, and then summation of forces, y. Okay. So, by looking at these three members here, yung mga missing natin na members, internal forces, if we apply summation of forces x and then summation of forces y in equations, wala tayong makukuha. Bakit? These three forces here or the three members here are all diagonal. Or I mean, yes, this one, 1 and 2, diagonal siya. So, meron siyang x and y component, yung CD and GH. And then CG also has one component, the horizontal component. So, tatlo yung missing natin dito. And, pag i-apply natin ang summation of forces x and y, wala tayong makukuha. 2 equations and then 3 unknowns, right? So, ang gagawin natin dito is apply first the summation of moment. Summation of moment tayo. Okay, so by taking the summation of moment at point G. Okay, at point G. Ay, saan yung G? Nandito yung G. G, D, E, and F. Yan. So, bakit tayo magmo-moment at point G? So, if we take the summation of moment here, automatic cancel out yung CG and GH. So, we are left with CD. No? Wala na tayong CD dito sa part na to. Therefore, CD, mako-compute na natin siya. So, CG and GH cancel out kasi they are directly connected dito sa point G. No? So, CD ang i-compute natin dyan. So, by taking the summation of moment at point G is equal to 0, counterclockwise positive. Okay. So, yung CD natin, diagonal siya. Therefore, meron siyang X and Y component. Right? So, dito na part na to, nandito yung kanyang X component and then another here for the Y, or for the X component rather. Okay. Kung idodrawing natin yan, ganyan. Ito yung FCD. So, nandito yung kanyang X component, FCDX, and then yung kanyang Y component, FCDY. Yan, ito yung dinawin ko dito. Okay, so determine naman natin yung slope niya. So for the slope, okay, so meron tayong 1 dito, then 1. Therefore, meron tayong square root of 2. Okay, so uniform na yung slope niyan. Kung ano yung slope dito, ganito rin dito, dito. Kasi makikita naman natin na tagwa 1 meter lang yung mga distances. So, uniform yung slope here. E hanggang A. Also with F hanggang J. Okay? So, let's begin. Apply natin yung CD. CDX. So, FCD, the component of this one, we have 1 all over square root of 2. Moment arm. Nagmo-moment tayo dito sa G. Therefore, the moment arm is 1 meter. Okay. Next. It will create a clockwise motion. Therefore, negative. Next. For the Y component. So we have, as you can see here, FCD. Nandito yon, di ba? Ito yung FCDY natin. And then, nandito yung point G. Dito tayo nagmo-moment, right? So, FCDY is acting directly sa ating G. Therefore, wala tayong distance, right? We do not have any perpendicular distance with point G. Therefore, the Y component of FCD is cancelled out. Okay. Pwede na nating i-cancel yan kasi yung FCDY natin is directly acting dito sa point G. Walang moment dito sa part na to. Okay. Therefore, susunod na natin yung mga external forces and support reaction. Okay. For our 2 kilonewton, sige, sulat ko na lang. So, sige, plus FCD, the Y component is 1 all over square root of 2 also. The distance, 0. There's no perpendicular distance. 2 kilonewton. The 2 kilonewton is applied directly sa ating point G. Wala ding perpendicular distance. Therefore, plus 2 kilonewton also multiplied with 0. And the next 1 kilonewton, it will create a clockwise moment. So, minus 1 kilonewton multiplied by 1 meter. And then yung ating EX, counterclockwise. So, plus 3.75 multiplied by 2 meters is equal to 0. Therefore, FCD is equal to, cancel out yan, cancel out. 1 divided by square root of 2 minus 1 plus 3.75 by 2. Therefore, FCD is equal to 9.192. No? We have 9.192 kilonewton. Okay, positive yung nakuha natin. Therefore, tama yung assumption. Therefore, FCD is in compression. Okay. Next, CG naman. CG. Okay, for our CG, ito yung kukunin natin, CG. Okay, by taking the summation of moment at point. Okay, hindi pa natin makukuha directly si CG. Meron na tayong CD. Yung FGH natin is slanted. Okay. Sige. So, we can take the summation of moment at point C is equal to 0. Okay, bakit ako nag-moment sa point C? So, dito sa point C, makakancel agad si CD and CG. So, we are left with GH. Okay, so i-compute muna natin si GH bago tayo makapag-proceed sa CG. Okay, so summation of moment at C is equal to 0. So, FGH, itong FGH natin, meron ulit siyang X and Y component. Yan. So, drawing natin dito sa part na to. Ito yung si FGH. So, meron siyang Y component and then X component. Then, meron din siyang slope. Kagaya ng slope dito. We have here 1 is square root of 2. 1 is square root of 2. Okay, sinet aside ko lang siya dito. Okay, so mag-moment daw tayo dun sa point C. So, pag nag-moment tayo sa point C, nandito yung X component ng GH, wala ulit tayong perpendicular distance, no? So, yung FGH multiplied by, ano yung perpendicular distance? Yung x0, diba? So, we have 1 square root of 2 for the x component, tapos 0. Ito yung FGH. FGH, x. Okay. Next, for the y component naman, minus, it will create a clockwise motion. Ito yung FGH, di ba? So, FGH multiplied by also 1 all over square root of 2. And then, the perpendicular distance of FGHY papunta sa C is 1 meter. Multiplied by 1 meter. And of course, cancel out na yung CD and CG kasi they are acting dun sa point C. Therefore, doon na tayo sa mga external forces. Unahin natin yung 2 kilonewton. So, minus 2 kilonewton, the distance 1 meter. Next, 1 kilonewton minus 1 by 2 meters. And then yung EX natin, minus or plus kasi counterclockwise. 3.75 kilonewton, the distance is 2 meters also. Okay, it's equal to 0. Therefore, FGH is equal to, cancel out na to. So, FGH is equal to 4.949 or, okay, 4.95. 4.95 kilonewton. Okay, positive. Therefore, FGH is in tension. Okay. The next, CG, yung hinahanap natin. Okay, for CG, we can now use. Lagay ko na lang dito since maikli naman na yung solution. So, by taking the summation of forces along X is equal to 0 to the right as positive. Okay, pwede na akong gumamit ng summation of forces X. Kasi na-compute naman na natin to 1 and 2. So, we have FCG. Next, the X component of CD. So, plus, anong FCD natin? FCD, 9.192. X component, 1 all over square root of 2. And the next, yung GH naman, this one, GH. Ito yung X component niya papunta sa left. Therefore, minus FGH, 4.95 multiplied by 1 is square root of 2. And then yung mga support reactions, yan, 3.75 minus 3.75 is equal to 0. Therefore, FCG is equal to square root of 2 minus 3.75. So we have 0.75. FCG is equal to 0.75 kilonewton. Okay, positive. Therefore, FCG, tama yung assumption. Therefore, it is in compression. Okay. So these are the internal forces of CD and CG respectively. So ito yung sagot natin. FCG and FCD. Okay, so proceed na tayo sa example number 2. Okay, bago yan, pwede nyo ring isolve yung CD and CG using the left portion, no? Ditong portion naman. Pwede. Parehas lang yung makukuha nyong sagot. So you may try computing CD and CG using the right or using the left portion also. Okay, so proceed naman tayo sa example number 2. So find the forces in members EJ and HD of the roof truss shown in the figure. EJ and HJ. Nasaan yan? So, we have EJ and HJ. Yan. So, nasa gitna siya. Okay. So, the first step here again is to solve for the reactions. So, meron tayong hinge dito. So, let's have a Y, a X, and then roller. Therefore, we have GY. Okay. So, taking the summation of moment at point A is equal to 0, counterclockwise positive. So, we have negative. Okay, unahin natin si GY. So, we have GY multiplied by 6 meters by 4. Yan, GY. Tapos 1, 2, 3, 4. Apat. Tag 6 meters yung kanyang moment arm. Next, yung mga external forces naman, unahin natin yung dito sa left part, the 3 kilonewton. So, we have clockwise motion, therefore, minus 3 kilonewton by 4 meters. So, kita naman natin sa taas na meron tagpo 4 meters dito. 1, 2, 3, 4. Okay. If I'm not mistaken, ito yung example natin doon sa joint. Hindi ko lang sure kung tama yung mga external forces na naka-apply, pero the truss itself is parang kamukha, no? Para lang naman, hindi ako sure doon. Okay. So 3 kilonewton multiplied by 4 meters. Mukhang hindi pare-parehas ng external force. 3, 4, 5, 3, 4. So, mukhang iba yung example natin sa joint. Okay, next, 4 kilonewton minus 4 kilonewton by 8 meters. Next, minus 5 kilonewton by 12 meters. Minus 3 by 16 meters. Minus 4 kilonewton by 20 meters. Is equal to 0. Therefore, GY is equal to GY is equal to 9.667. 9.667 kilonewton. Double check lang natin. X24 minus 12 minus 32 minus 60. 3 times 16 tapos 4 by 20. Okay, so GY is equal to 9.667 kilonewton. And then taking the summation of forces, X is equal to 0. So wala tayong nakikitang any horizontal forces. Therefore, AX is also equal to 0. And then summation of forces Y is equal to 0. Upward positive. Therefore, we have AY plus GY minus 3 kilonewton minus 4 minus 5 minus 3 minus 4 is equal to 0. Where GY is equal to 9.667 kilonewton. Therefore, AY is equal to 3 minus 4 minus 5 minus 3 minus 4. So we have 9.33. AY is equal to 9.333 kilonewton. So these are now the external or support reactions. AY 9.333 kilo. Okay, so we are done with getting the reaction. So proceed naman na tayo dun sa cutting line. So our cutting line, we will make sure that dadaanan niya yung ating members of interest. And our member of interest here is members EJ and HJ. Okay. EJ and HJ. So basically, dito tayo magka-cut. Ayan.
So, dito dadaan yung ating cutting line, AA. After that, drawing na natin yung free body diagram. So, I will choose the right portion. Right portion tayo. And again, kung pipiliin mo yung left portion, wala rin namang problema. Okay. So, nandito yung ating cutting line. Ayan. Tama ba? So, 1, 2, 3. Okay. And then, don't forget yung ating mga external forces. So, here, meron tayong 4 kilonewton. 3 kilonewton. GY, 9.667 kilonewton. What else? Okay, the dimensions. We need the dimensions here. This is 6 meters, right? 6 meters. Tapos, this one, 4 meters. Another 4 meters. Okay. Then, reflect na natin yung mga internal forces of the members. So, here, meron tayong wait lang. Sige. Dugtong na lang natin para makita natin later on kung saan tayo magmumove. So, nandito yung J. Joint J. And then, dito yung D. So, for our JH, again, mag-a-assume ulit tayo ng direction of the forces. So, here, I would assume that this is in tension. Okay, tension. EJ, let's say, compression. Again, assumption lang itong mga to. Pwede magbago later on. And then, yung ating DE is, okay, let's say, tension naman siya. Palakihan lang natin yung mga forces. And then, ED natin, tension. So, tawagin natin itong FEJ. And then, this one is FHJ, FDE. Okay. So, let's start. For me, I would take the summation of moment at point E. Okay. So, I will take the summation of moment at point E. Bakit ako magmo-moment sa point E? So, as we can see here, naka-connect yung ating EJ and DE, no? So, basically, wala nang moment dito sa part na to. DE and EJ canceled, or we can neglect that kasi walang moment. HJ, ayan, meron tayong horizontal force dito. So, pwedeng mag-create ng moment at point E. So, makukuha na natin agad dito si HJ, FHJ. Okay. So, taking the summation of moment at E is equal to 0. So, FHG or FHJ multiplied by, okay, so kailangan natin dito ng distance, no? Distance. Okay, based on our illustration, 10 meters to. Okay, so ito yung hinahanap kasi nating distance, guys. Ito. So, how? Okay, so pwede tayong gumamit dyan ng ratio and proportion, no? So, for this one, ito, i-consider natin itong triangle na to. Yan, kasi yan yung given yung distance together with the triangle here. Okay, so tawagin natin yung Y. Okay, so by ratio and proportion, yung larger triangle natin. So, we have, dito ko na lang isulat, We have 10. So, 10 all over, ilan yan? 12 is equal to y all over, ano yan? 6 tapos, ito, 4 and 4. So, 8. 8. Therefore, y is equal to 80 divided by 12. So, y is equal to 6.667. Okay. 6.667. 667. So, FAJ, now the moment arm is equal to 6.667 meters. Next, balik tayo dito. Yung mga external forces naman. So, 3, nagmo-moment tayo sa point E. Therefore, yung 3 kilonewton is makakancel also. Therefore, 4 kilonewton na tayo. So, minus 4 kilonewton multiplied by the moment arm of 4 meters and then yung ating support reactions na 9.667. So, it will create a counterclockwise motion, therefore plus 9.667 kilonewton multiplied by 8 meters. Okay. It's equal to 0. Therefore, FHJ is equal to 4 plus 9.667 by 8. So we have negative 9.2. So negative 9.2. Therefore, mali yung assumptions natin dito for the direction. So HJ, am I right? To FHJ. Double check lang natin guys. FHJ. Okay, I'm so sorry. This FHJ is nag-moment tayo sa either 4. Okay, clockwise motion pa. So negative. What about the others? Double check natin. So 4. Okay. Mali lang ako dito. Hindi ko nalagyan ng negative. So plus 9.2 kilonewton. Okay. Tama yung assumptions natin in tension. Okay, next. Tapos na tayo sa isa, HJ. Proceed naman na tayo sa EJ. EJ, din dito tayo. Ayan, EJ. Therefore, we will take okay. So, we will take pwede tayong mag-summation of forces X dito, summation of forces Y, kasi we have two unknowns, two equations, so mako-compute na natin siya. Present naman si HJ. Present naman na kasi si HJ. Pwede rin tayong mag-moment dun saan tayo mag-moment? Okay. We can take the summation of moment at point J. Okay. Taking the summation of moment at point J is equal to 0. Counterclockwise positive. Okay. Pag nag-moment tayo sa point J, lutang, EJ pala yung hinahanap natin. Sorry. Kasi pag nag-moment tayo sa point J, cancel out si EJ, di ba? Iyan yung hinahanap natin. Mali. Erase natin yan. Okay. So, taking the summation of moment at point D. Okay. So, pwede tayong summation of moment at point D. Okay. Pag nag-moment tayo dito sa point D, so automatically cancel out si FDE. Si FEJ, makukuha natin by using the X and Y component. Tapos si FHJ, present naman yan. So, walang problema if we take the summation of moment at point D. Okay. So, game. So, FHG, unahin natin si FHG. And FHG is 9.2 kilonewton. Okay. Nagmo-moment tayo dito sa point D dito. And then, the moment arm is equal to 10 meters. And it will create clockwise moment. So, minus. Okay, next. FDE, cancel out na yan kasi makikita natin directly siya pointing to T. Okay. And then, yung EJ natin, meron siyang X and Y component. Yan. So, kailangan nating hanapin yung slope for EJ. para ma-determine natin yung x and y component. So, dito, ito yung slope na hinahanap natin, guys. Yan. Okay. So, meron naman na tayo dito. Nakuha na natin kanina. Drawing ko lang. Itong part na to. Ayan. So, we have here, yung y natin kanina is 6.667. Tapos, yung horizontal, 4 meters. Yan. So, alam na natin yung slope dito. Na? So, that is 4 square root of 4 squared plus 6.667. So, we have 7.77. 7.77. Kasi yung slope natin dito, hinamit lang natin yung triangle na nabuo natin kanina. So, ito yung slope na gagamitin natin. Okay, so 9.29 natin yung x component niya. So, for the x component, we have FEJ. FEJ 4 all over 7.77. Okay, next, nagmo-moment tayo sa point D, so it will create a counterclockwise motion, so plus. Moment arm, nandito tayo sa part na to. The moment arm is equal to, ayan, kailangan natin maghanap ng moment arm. Kung yung y natin kanina is 6.667, so it is just 10 minus 6.667. So, 10 minus 6.667. Okay, okay na tayo sa x component. Next naman is sa y component. So, y component natin, it will create a counterclockwise moment also. So, FEJ, y component is 6.667 all over 7.77. Moment arm, again, nandito tayo. Nandito tayo sa point na to. Nagmo-moment tayo sa point D. So, we have 4 meters. Okay. And then, yung mga external forces, yung 3, 4. So, clockwise motion. So, 3 kilonewton. So, minus by 4 meters. Nandito na tayo. Oh, yan. Yung dito. 3 kilonewton. 4 meters to. So, 3 by 4 meters minus 4 kilonewton by 8 meters. And then, yung support reactions plus 9.667 multiplied by 12 meters is equal to 0. Therefore, FEJ is equal to 4 divided by 7.77 multiplied by 10 minus 6.667. 77. 4. It's 32 plus 9.667 by 12. So, FEJ is equal to 3.884. 3.884. Yan. 3.884 kilonewton. So, tama yung assumptions natin. Therefore, it is in compression. Okay. So, we are already done with the unknowns. Ang pinapahanap sa problem is the member FHJ and FEJ. Ayan. Okay, so proceed na tayo sa example number 3. Determine the force in member BD and DE of the truss shown. Member BD, ito yun. And member D. Yan. Okay, game. So determine na natin yung mga support reactions here. Okay. So, meron tayo ditong Fx, Fy, and Gy. Okay. So, by taking the summation of moment at point F is equal to 0, counterclockwise positive. So, we have Gy multiplied by the moment arm, 4.5 meters. Next, minus 135 kilonewton by 2.4 meters minus 135 ulit by 2.4 multiplied by 2. Nandito na tayo sa force na dito. And then next, minus 135 kilonewton by 2.4 times 3 is equal to 0. Therefore, Gy is equal to 135 by 2.4 minus 135. So, Gy is equal to 432. Double check natin. X, 4.5 minus 135 of 2.4 minus 135 of 4.8 minus 135 by 2.4 times 3 is equal to 0. Okay. Therefore, Gy is equal to 432 kilonewton. Okay. Next, taking the summation of forces along y is equal to 0, upward, positive. So, Fy plus negative Fy plus Gy is equal to 0. Therefore, Gy is equal to 432. Therefore, Fy is also equal to 432 kilonewton. Okay. And then, taking the summation of forces, x is equal to 0 to the right as positive. So, negative Fx. Okay, nagkataon lang to. Summation of forces at x and then yung Fx natin dito. So, summation of negative forces x. So, negative Fx plus 135 plus 135 plus 135 is equal to 0. Therefore, Fx is equal to 135 times 3. We have 405. 405 kilonewton. Okay, so those are the forces or support reactions. 405 Fy 432 kilonewton, also Gy 432. Okay. So next procedure is to have the cutting line or the cutting plane and make sure that yung cutting plane ulit natin will pass on the members of interest and preferably 3 members yung dadaanan ng ating cutting line. Okay. So, BD and DE yung interest natin, member of interest. Therefore, we can have our cutting line here. Ayan. Tawagin natin AA. So, it will pass on BD, DE, and EG. So, BD and DE lang naman yung kailangan natin. Okay. So, I would like to isolate yung ating lower portion. And again, you can use the upper portion in computing the unknowns. Okay. Okay, so problem pala na to, no? Since kinuha natin yung reaction, pwede natin gamitin yung nasa baba. Pag ginamit naman natin yung portion sa taas, okay lang na hindi na natin i-compute yung mga support reactions, right? Kasi pag itong upper portion yung kinuha natin, tama. Pag upper portion yung kinuha natin, hindi na natin kailangang i-compute si reactions. Yes. Okay. Sige. So, lower portion. Sige, try natin later on yung lower tsaka upper portion. Tignan natin kung tama ba yung sinasabi natin kanina. Kung kahit anong portion i-consider mo, same pa rin yung magiging sagot. So, unahin muna natin yung lower portion. Okay. kunwari, ito yung ating cutting line. So, we have here 432 kilonewton. And then 405. The GY of 432. And yung ating external force, we have here 135. And then, of course, the distances. We have here 2.4 meters. And then 4.5 meters. And then, reflect na natin yung mga internal forces, which is the BD, DE, and EG. So, for our BD, let's assume na lang then that the internal force is... Okay, assumption lang naman. So, tension. And then dito, we have here compression. And then, here, meron naman tayong compression ulit. Okay. So, tawagin natin itong FBD, FDE, and FEG. Okay. This is the joint E. Okay. So, game. Okay. Dito, pwede natin gamitin agad yung summation of forces X is equal to 0 to the right as positive. Why? Because the other two forces here are vertical. Both vertical. So, cancel out agad. Okay. So, taking the summation of forces X is equal to 0 to the right positive. So, we have negative FDE multiplied by negative FDE plus 135 kilonewton, then external, and then yung support reactions natin to the left, so minus 405. What else? Okay, is equal to 0. So FDE is equal to we have negative 270. Okay, mali yung assumption natin. So, negative 270 kilonewton or 270 kilonewton in tension. In tension. Next, BD na lang. So, for our BD, we can utilize taking the summation of moment at point E. Okay. So, if we take the summation of moment at point E, automatically, makakancel si FDE and FEG. Right? FEG and FDE will be cancelled out. Therefore, makakompute na natin agad si FBD. Okay. Taking the summation of moment at point E is equal to 0, counterclockwise positive. So, FPD, it will create a clockwise motion, so minus, and then the moment arm is 4.5 meters. 4.5 meters. Next, may cancel out yung FDE, FGE. Makakancel din si 135, right? Okay. And then, makakancel din si 432. Ayan. Nakadirect lahat sila sa joint E. So, cancel. Walang mga moment arm. And then, we are left with 405 and 432. So, 405, it will create a clockwise motion. So, minus 405 multiplied by 2.4 meter as the moment arm. And then, yung 432, it will create a counterclockwise. So, plus 432 multiplied by 4.5 is equal to 0. Therefore, FPD is equal to 4.5 minus 405, 2.4 plus 432 by 4.5. So, FBD is equal to 216 kilonewton. Okay, tama yung assumptions natin dito sa part nito. So, positive 216 kilonewton in tension. FBD is equal to 216 kilonewton in tension. Okay, so we are done with the unknowns. Ito yung magiging final answer natin. FPD and FDE. Okay. So, dito papaganahin lang natin ng kaunti yung imagination natin. Unlike din kasi sa method of joints, paulit-ulit lang yung gagawin kasi natin doon. Summation of forces X, summation of forces Y, di ba? Mag-a-isolate tayo ng joint, and then, apply natin yung summation of forces X, summation of forces Y. Ganun din, lilipat ulit tayo sa kabilang joint, summation of forces X, summation of forces Y. So, paulit-ulit lang. Unlike dito sa method of section, may utilize natin yung summation of moment X and Y. But make sure also na tama yung inyong cutting line dito. Para hindi kayo mahirapan mag-imagine kung ano yung iti-take yung moment. Okay, practice lang yung kailangan natin dito. Okay, so proceed na tayo sa last example. Okay, for a signboard. So the signboard truss supports the load as shown. Determine the forces in members CD, CE, and EF. Okay, so tatlo yung members of interest natin. CD, CE, and EF. Ayan. Okay. So by now, siguro nakikita nyo na kung saan kayo magka-cut. Okay, but before the, wait lang. As I have said kanina pala, we will also compute, no? The BD and DE using the upper portion. Okay, sige. Para makita natin kung tama yung pinagsasabi ko kanina. Na kahit anong portion yung gamitin mo is same pa rin yung lalabas na sagot. Okay. Ang advantage kasi pag kinonsider mo yung upper portion, okay na kahit hindi mo i-compute yung mga support reaction. Pwede mo nang i-jump yung procedure number 1. Okay. So, upper portion naman yung i-drawing natin ngayon. Then, nandito yung cutting line natin. Okay. So, BD. Assume na ulit natin yung direction. Hindi ko na naalala yung assumption ko kanina. And then, next one, we have here. Okay. So, ganyan naman yung assumption natin. And then, sige. Tawagin natin itong BD, FDE, and FEG. And then don't forget the external forces. 135 and another 135. And then the dimensions here. 2.4 meters and then 4.5 meters. Okay. So, ito yung magiging free body diagram natin. Okay. So, kagaya dun sa una nating solution kanina, we can now compute DE kasi nga yung BD natin in EG are both vertical. So, by taking the summation of forces along X is equal to 0 to the right as positive, so FDE, yan, FDE to the right. Okay, nakikita ko mali na yung assumptions natin dito. Okay, so plus 135 plus 135 is equal to 0. So, FDE is equal to negative 270 kilonewton or 270 kilonewton in tension. Okay. Next, ang kailangan natin is BD. BD. Okay. So, ganun din. If we take a moment here at point E, taking the summation of moment at point E, makakancel yung DE and AG natin. So, we are left with BD. So, yan naman yung hinahanap kasi natin. So, taking the summation of moment at point E is equal to 0, counterclockwise positive. So, FBD, negative FBD, multiplied by 4.5. And then, yung mga external forces natin. So, we have minus, wait lang, FBD is a counterclockwise. So, plus. 135 yan yung clockwise. So, 135 multiplied by 2.4 meters. Ito, yung 135 na to, papunta dito. This is also 2.4 meters. Next, minus 135 by 2.4 plus 2.4 is equal to 0. So, FBD is equal to x of 4.5 minus 135, 2.4 minus 135, 2.4 times 2. So, we have 216 positive. FBD, 216 kilonewton in tension. Okay, in tension. So, tama, parehas yung lumabas na sagot for the lower portion and then pag kinonsider natin yung upper portion. Okay, so next example na tayo. Example number 4, the last example. So, ito i-consider natin DE, CE, and FE. Okay. So, first is to consider or to compute for the external support reactions. Sana yung pen? Yeah. So, we have here a hinge. So, let's say we have here a Y and then a X and then also here P Y. Okay. By taking the summation of moment at point A is equal to 0, counterclockwise positive. So, we have BY multiplied by moment arm ng BY. 1, 2, 3, 4, 5, 6. So, 3 meters multiplied by 6. And then, yung mga external forces natin, starting here at 2 kilonewton. So, minus 2 kilonewton by the distance of 3 plus 6, 9 meters. Next, minus 2 kilonewton ulit, moment arm 3, minus, nandito na tayo, minus 2 by 6, minus 2 by 9, minus 2 by 12, minus 2 by, sana tayo 2 by 12, 1, 2, 3, 4, 1, 2, 3, 4, 5, 2 by 15, ayan, is equal to 0. So, BY is equal to 18 minus 18 minus 6 minus 12 minus 18 minus 24 minus 30. Therefore, BY is equal to 6 kilonewton. And then taking the summation of forces, X is equal to 0 to the right as positive. So, we have negative AX plus 2 kilonewton is equal to 0. So, AX is also equal to 2 kilonewton. And taking the summation of forces Y is equal to 0, upward positive. We have AY plus BY minus the external forces, 2 minus 2 minus 2 minus 2 minus 2 is equal to 0. BY, 6 kilonewton. Therefore, AY is equal to 6 minus 1, 2, 3, 4, 5 minus 10. So, we have 4 kilonewton. Okay. 4 kilonewton. AY. AX, 2 kilonewton. BY, 6 kilonewton. Okay. By now, nakikita nyo na siguro kung saan tayo magka-cut. Kapag ginamitan natin yan ng method of joints, aabutin tayo dyan ng siyam-siyam. Okay. So, CD, C, and EF. So, dito tayo magka-cutting section. Tatawagin natin A, B. Okay. So, left or right portion ulit. So, for me, okay, gamitan na lang natin ng sige, left portion na lang. Wala namang problema. Left portion. Okay. So, medyo complicated pa yung drawing natin kung mamano-manuhin ko pa, no? So, dito ko na lang i-reflect. Imagine na lang natin na wala. Sige, drawing ko na nga lang. Para hindi kayo malito. Okay. And then, yung cut natin. Okay. Imagine dito tayo nag-cut. So, external forces, 2 kilonewton. 2 kilonewton. 2. And then we have here 4 kilonewton and 2 kilonewton. F, C. So, nandito yung another joints, D and E. Okay. And then the dimensions, we have here 3 meters and then another 6 meters. And then tag 3 meters for the horizontal. Okay. And then reflect natin yung mga forces na kailangan natin dito. So for CD, let's assume na lang yung directions dito. Hindi na. Okay, compression tayo dito. Tapos dito naman, let's say also compression. And then tension. Okay. Tawagin natin itong FCE, FCD, tsaka FEF. Okay. So, yan. Okay. So, start na tayo to apply the 3 equations of equilibrium. So, by taking the summation of, taking the summation of moment at point E. Again, hindi natin maia-apply yung summation of forces X and Y muna dito kasi 3 unknowns pa yung meron tayo, no? 3 unknowns pa. So, ang kailangan natin dito is summation of moment muna. So, pag nag-summation of moment tayo at point E, automatically cancel out na si CE tsaka CEF. So, makakompute na natin ngayon si CD. Taking the summation of moment E is equal to 0, counterclockwise positive. So, we have CD. Again, cancel out na si EF tsaka si CE. So, FCD tayo. So, FCD, it will create a counterclockwise moment. So, positive. Moment arm niya is 3 meters. And then, yung mga external forces and then support reactions naman. So, counterclockwise moment din. Yung rotation nila. No? So, we have plus 2 by 3 meters. Ito, 3 meters. Next, plus 2 kilonewton by 6 meters. And the next, yung horizontal natin, clockwise. So, minus 2 kilonewton by 3 meters. Tapos, the support reactions, minus 2 kilonewton by 6 meters. And then, 4 kilonewton naman, minus 4 by 12. Ay, no, 9. 3 tapos 3. So, 9 meters is equal to 0. So, FCD now is equal to x3 plus 2 by 3 minus 12 minus 36. Okay, so FCD is equal to 12 kilonewton. So, positive, tama yung assumption natin dito. So, 12 kilonewton na CD in compression. Next, summation of Okay, so dito, magsa-summation of moment ulit tayo, no? Summation of moment at, again, CD, okay na tayo. So, CE and EF na lang. So, summation of moment at point C. Okay. So, equal to 0, counterclockwise, positive. So, pag nag-summation of moment at point C tayo, automatically maka-cancel out si CD tsaka si CE. So, we are looking for EF on this part na, EF. Okay. So, FEF. So, it will create a counterclockwise moment, so positive, multiplied by 3 meters as the moment arm. And then yung mga external forces na natin. So, ligwak na si 2 kilonewton, no? Kasi it is directly at point C. So next tayo dito, 2 kilonewton. So, we have counterclockwise. So, plus 2 kilonewton multiplied by 3. Next, ito naman, cancel out also kasi they have the same line of action with point C. No? So, wala silang perpendicular distance. So, dito na tayo sa support reaction. So, minus 4 by, the distance is 6 meters. And then, yung 2 kilonewton dito, minus 2 ulit by 9. Tama ba? Yes, 9 meters is equal to 0. Therefore, FEF is equal to plus 6 minus 24 minus 18 is equal to 0. So, FEF is also equal to 12 kilonewton. 12 kilonewton. So, tama yung assumptions natin. Therefore, 12 kilonewton by tension. Yes, tension. EF, tension. Okay, next. Next, proceed naman tayo sa CE. Okay. CE na lang yung kulang natin dito. So, for our CE, we can use either summation of forces X or summation of forces Y. So, present naman na yung CD natin tsaka EF. So, for me, gagamitin ko na lang yung summation of forces Y para hindi na natin pakialaman si EF tsaka si CD. They are both horizontal na. So, summation of forces of Y is equal to 0 upward, positive. So, we have FCE. Ito, FCE. Kukunin natin yung kanyang Y component. Okay. So, yung FCE natin yan, di ba? So, meron siyang Y component. Tawagin natin FCE Y, tsaka X component na FCE X. Okay. So, kailangan natin yan ng slope. So, for our slope, nandito tayo. Ito, CE. So, the slope is equal to 3 meters, tapos ito 3. So, we have 3 square root of 2. Okay, 3 square root of 2. So, FCE, Y component tayo because we are taking the summation of forces Y is equal to 0. So, FCE multiplied by 3 all over 3 square root of 2. Okay. Next, external forces na tayo. Minus 2 kilonewton na minus 2. Then, support reaction plus 4 is equal to 0. Therefore, FCE is equal to, okay, kung mapapansin nyo, hindi na natin pinakialaman yung dalawang forces na na-compute natin kanina. Mas umikli yung equations natin pag gagamit tayo ng summation of forces along Y. Okay, so here, FCE is equal to 0. Okay, so 0 force member pala yung CE natin. FCE is equal to 0. Okay. Therefore, ito na yung mga hinahanap natin for our final answer. Okay, so that ends our lessons for chapter 5. If you have any clarifications or questions, you may message me at the group chat or you may approach me at the faculty room during my consultation hours. Okay. So our chapter 5, kindly have a review and I will announce the examinations soon. Thank you for listening. Have a good day.